I'm Luke Seibel, this is PhyziX, and these are vectors. So how can we apply these vectors? Well, let's imagine that we have a box that's just sitting on a flat surface, like that. Here's our box. And this box we're going to say is 1 kilogram, just to make things easy. And so we know that one force acting on this box will be the force due to gravity. And if the force due to gravity is mass times acceleration, and the acceleration due to gravity is 9.81, then we just multiply 9.81 meters per second times this 1 kilogram, giving us 9.81 newtons. So let's draw a little vector for the force due to gravity. So the force due to gravity will often be shown by an FG, left little subscript G, or sometimes a W for weight. This is because weight is a force, whereas mass is a measurement of how much of something is. Something's mass will be the same no matter where you are, whether you're on the moon or on Earth. Weight will change depending on the force due to gravity, because weight is a force. And so this will be equal to 9.81 newtons. Now, as we learned before, in Newton's laws, Newton's third law states that every action has an equal and opposite reaction. So there will be an equal and opposite reaction to this force. And so if it's equal, then it will also be 9.81 newtons, and it will be in the opposite direction. So this is often called the normal force, so N, which also will equal 9.81 newtons. And we're also going to have to define a direction. So we're going to say that if downwards is negative, then this will be negative 9.81. So let's just add that in there, a little negative sign. So if this is the case where the two forces are equal and opposite, then they will cancel each other out, resulting in zero net force. And so therefore the box will remain stationary, provided no other force acts on it, as we learned in Newton's first law. Alright, let's imagine we have that same box, but this time it's sliding down a ramp. So here's our ramp, and here is our box, which is still 1 kilogram. So the force due to gravity will still be acting on this box. So we'll denote that with a vector with a little FG. And so the equal and opposite force will, again, be equal and opposite. However, the normal force is always perpendicular to the surface on which the object in question is moving. And this is because the normal force is the force of the surface acting back on the box. So if this is the equal and opposite force, the normal force will actually be the component of this that is perpendicular to the surface on which the box is moving. So perpendicular, this component of it. So that will be your normal force. We'll denote that with a little n. And now, because these vectors are the two forces that are acting on this box, then the resultant vector can be shown by adding these two vectors together. So if we add that normal vector on to the vector that denotes the force due to gravity, then we see that the resultant force is given by this little green vector, and this will be the box's direction of motion, and that's why the box will slide down the ramp. And so we'll put this in as the resultant force, so FR. Alright, so now if we imagine that the angle of this slope is 30 degrees, then we actually have all the information we need using some simple trigonometry and some equivalent triangles to figure out the values of each of these vectors. So first of all, we know that the force due to gravity we figured out before is 9.81 newtons, because it's its mass times its acceleration. Its mass is 1 kilogram, its acceleration is 9.81 meters per second squared, So multiply those two things together and you get 9.81 newtons. But now, what are these two? What's the value of these two vectors? Well, first, by looking at these equivalent triangles, we can figure out that this angle is actually also 30 degrees. This angle is 30 degrees, and this angle is also 30 degrees because these two triangles are actually the same. If that hypotenuse is the same as that hypotenuse, and this is the same as the normal force, then and these two lengths are also the same, then these triangles are equivalent, and this will be the same angle for both. And so now first let's figure out what n is. Well, if we know what FG is, then we know what the hypotenuse of this is, and we're trying to find out what the adjacent side to this angle is. So going back to some trigonometry, we know that the cosine of an angle is equal to the adjacent side over its hypotenuse. And the adjacent side in this case is n. Sorry, let's change the color and make that more clear. The adjacent side is n, and the hypotenuse side would be FG. So let's write that down. FG. Alright, so now let's put in the variables we know. And so if theta is 30, then we have cos 30 is equal to n over 9.81 newtons. 9.81 newtons. And so now, with some simple algebra, we can figure out what n is. And we get that n is equal to cos 30 times 9.81 times 9.81. And this will come out to be n equals 8.49 newtons. So the normal force of this would be 8.49 newtons. Alright, next let's figure out what the value of the resultant force would be. Well, if we know that this is the adjacent side, then this must be the opposite side. So this too will be the opposite side. And so when we have an opposite side and the hypotenuse, then we can use the sine function. And so sine theta will be equal to the opposite side, which in this case is the resultant force, Fr, over the hypotenuse, which is, again, in this case, force due to gravity. And so, again, we input all the variables that we know. So sine 30 is equal to Fr, resultant force, over the force due to gravity, which is 9.81 newtons, 9.81 newtons, and then rearrange it like we did before to isolate the resultant force. Fr will be equal to 9.81 times sine 30, and that will come out to be 4.91. So let's write that down. Resultant force, let's change it, let's make it green. Resultant force, Fr, is equal to 4.91 newtons. So the box will be moving down the slope with a force of 4.91 newtons. And actually, if we divide it by its mass of 1 kilogram, then we will get its acceleration, which will also be 4.91 newtons. So if you're ever having trouble wrapping your head around a question, it can be actually incredibly useful to figure out what the different forces are that are acting on it and write down the different force vectors. And then this can help you see what potential resultant forces will be, and using the information that you're given, you can even calculate the values of all these forces. And as one of my teachers once told me, that almost any problem you're going to have in physics, in engineering, in chemistry, in math, or maybe even in life can be represented by a box on a ramp. And by figuring out the different forces acting on that box, you're going to be able to come to an answer.